Okay, hello everyone. So today I will give a short lecture about scalar and vector quantities. This is officially our first topic in physics. So let's say a grade 7 student goes up to you and he still has no idea about where the buildings are in the campus. He's in the chapel, as you could see, and he asks you a simple question. How far is the cafeteria from here? Well, one answer that you might probably end up giving is something like 200 meters. And so he takes those directions, walks 200 meters, and he ends up in the wrong place. This is actually Montserrat Wing in the modern day. Back in my day, it was the third year quadrangle because third year high school students would be there, but now it's Montserrat. So one thing that was missing from your instruction was to give him direction. So now you could actually say 200 meters north. And with that, he now knows where exactly to go. You walk 200 meters in a certain direction. So in the first scenario, you were just giving the distance and he got lost because he didn't know where exactly that distance was headed. But in the second scenario, you had both distance and direction. And this is actually the difference between a scalar and a vector quantity. So a scalar quantity is a quantity which is fully described by its magnitude, and a vector quantity is a quantity which is fully described by its magnitude and direction. So just a few jokes to insert over here. You need direction in life. That's all it's trying to say basically. But anyway, so for example, you have 350 ml of water. This is just a numerical value, therefore this is a scalar quantity. 55 miles per hour. Now I know that when you're driving or traveling in a car, you're probably going a certain direction. However, the speedometer doesn't really tell you that. It just tells you what speed you're going. It's just a number. Scalar quantity. Go straight for 0.5 miles. Well, this time you have a directional cue over here. Go straight. And you also have a numerical cue, 0.5 miles. That is a vector quantity. Let's say you're building something in Minecraft and it says the tower height is 50 blocks. Well, this time, it might sound confusing, but height is actually simply a dimension of the building. This is height, okay? It's just a numerical value, therefore this thing is actually a scalar quantity. One way to make it a vector quantity is to explicitly say the top of the tower is 50 blocks above the ground. So now you have a term above the ground. Now you have a certain direction, and now this is a vector quantity. So vectors are quantities with magnitude and direction. They are represented by an arrow with a tail and a head, and actually each vector can be represented by a letter like R with an arrow on top, or A, it could be B, or any letter in the alphabet. The length of the arrow is ideally proportional to the magnitude. So what do I mean by that? So for example, you have a vector 5 kilometers north, and you have another vector 3 kilometers west. So when you draw those two vectors, you ideally have to make it proportional to each other by making this, say, 5 cm long and making the other one around 3 cm long. Why? So that you can have a representation of how big a certain vector is compared to the other. And this can actually help in terms of your geometrical, or rather your drawing of vectors, but we'll get to that later on. And there are three ways to describe direction. So one is by degree measure, 120 degrees, that's just the angle. Two is by directional cues, so north, south, east, and west. And there is actually another way to do it, and that is to use both. So for example, 30 degrees west of north. So when you're given something like this, it might sound confusing, but you first look at the second bit, north. So direction of north is going this way. And when you say west of north, west is actually going here. This is the west. So to the west of north would be to go that way. And all you have to do is count up 30 degrees. That's your angle, 30 degrees west of north. Now let's say you want to add two vectors. When you have a tailwind situation, which is when the vectors are in the same direction, you will add. So when they're in the same direction, like a paper airplane, it theoretically should go faster if there's a wind blowing behind it. So let's say you throw it at 8 kph and the wind is 6 kph, your plane will fly at 14 kph. If you have a headwind situation, wherein you're throwing against the wind, you will actually end up making the plane go slower. So for example, 8 kph, you throw it against the wind at 6 kph, you're going to end up with just 2 kph because you will add the negative or subtract. A crosswind situation is something a little bit different. So let's say the plane is traveling forward at 8 kph and the wind is blowing that way at 6 kph. Does it go directly north? Well, it does not. It doesn't even go directly to the right either. So what do you do when you have a crosswind? Well, one way to get the shape would be first use the parallelogram method. So to use the parallelogram method, one is you have to draw two parallel lines to the vector. So as the name suggests, parallelogram, a parallelogram, if you remember your math, is two parallel lines. That's what defines a parallelogram. So if you draw it something like this, two parallel lines, and then you go from the two tails up to the point that you just drew. That's your resultant vector. Okay? Another way to do it would be the tail to head method. So there are two tail to heads in this kind of method. So first is to put the tail of one on the head of the other. Sorry. Tail of one on the head of the other. 4, 5, 6. Again, as you can see, I'm drawing proportionally. And then, after you draw the tail of one on the head of the other, then you connect the tail of one to the head of the other. So another tail to head situation, and you have the tail to head method. So how do you get the magnitude of this resultant vector? Well, we know it's 10 kph, but how exactly did we arrive at 10 kph? You already know what direction it would go to, but you don't know about the magnitude. Well, if you notice, this is actually a right triangle. And one way to solve for the hypotenuse of the right triangle, or the longest side, is to use your Pythagorean theorem. A squared plus b squared equals r squared. So if we actually try to solve this, 6 squared plus 8 squared is r squared. Okay, so 6 squared is going to be 36, 8 squared is going to be 64, equals r squared. And to get the square root, to get r, you have to square root both sides. So 36 plus 64 is 100, equals r. And that will leave you r is equal to 10. So 10 kph. Now, how do you get the angle? One way to get the angle is by using something called SOHCAHTOA. So that is an acronym. However, when you have SOHCAHTOA, all you actually need to note is TOA. So TOA means tangent equals opposite over adjacent. So how do we do that? So for example, in this angle here, you want to get that angle. So tangent of that angle is equal to opposite over adjacent. The opposite side to the angle is 8 kph. The adjacent side to the angle is 6 kph. So that's going to be equal to 4 over 3. Now, to get the tangent of or to get theta in itself, we actually go to the inverse. So tan raised to negative 1 of 4 over 3 equals theta. This might sound complicated at first, but trust me, it's just a simple plugging into a calculator to get this answer. So tangent inverse of 4 over 3, and you will get something like 53 degrees for your angle. So that is how to get the angle using SOHCAHTOA. Now, there are other cases wherein you are given something that's not necessarily perpendicular to each other, and you have the sine law and the cosine law to help you out in that regard. So in the case of the sine law, you will have r is equal to a r over sine of r, is equal to a over sine of a is equal to b over sine of b. And for cosine law, r squared is equal to a squared plus b squared minus 2ab cosine of a. Now, in this case, we will not actually ask you to use and apply these laws, but I just want you to know that these laws exist. Let your math teacher educate you about sine and cosine laws when you get to trigonometry. So now we can practice. Solve for the resultant of these vectors. So when you have two vectors going in the same direction, 5 and 5, you will get 10 going in that direction. East, you just add them up. When you have them going at the opposite direction, you will add the negative or subtract. So 5 minus 5 gets you 0. Take note that if you have a 0 vector, you don't need to put the direction because 0 is nothing. If you have 5 and 10 going in the same direction, you add them up, 50 newtons to the east. If they go in the opposite direction, 5 and negative 10, you have 5 newtons to the west. Now, here's a common confusion. Because if you say 5 newtons to the west, that's very different from negative 5 newtons to the west. Why? Because negative 5 newtons to the west actually is going east because that's double negative. If you have 5 going to the east and 15 going to the west, add the negative, you're going to get 10 going to the west. 10 going up and 5 going down. So you will have 5 newtons going north. And when you have something like this, 4 going up and 3 going to the west, you will now have to use Pythagorean theorem, or one of the methods to get the direction of vectors. So 4 going up, let us use the tip to tail method, or the tail to head method rather. So 4 going that way, let's put the tail to the head, 3 going that way, and then connect. You'll have a right triangle, and if you notice, this is actually a Pythagorean triple. This is a Pythagorean triple. What do I mean by that? So that's 3, 4, 5. These sides actually make a perfect right triangle. So that means the resultant of this one is going to be 5. That's the hypotenuse. You can plug that into the Pythagorean theorem if you don't believe me, but I'm telling you right now, as a Pythagorean triple, this is going to be 5 for the hypotenuse. Now to get the angle of that, you go tangent of theta is equal to the opposite side. Where's the angle that we're looking at? Let's look at this one. The opposite side of that is the 4. The adjacent side is the 3. And when you get the tangent inverse of 4 over 3 to get theta, that's actually similar to what we solved a while ago. This will be around 53 degrees. So that angle over there is 53 degrees. However, it says 36.87 west of north. Why? Because that's actually subtracted from 90 degrees. So if you subtract 53 degrees from 90 degrees, you'll actually end up somewhere close to 36.87 west of north. Okay? So I hope that my lecture today on scalars and vectors enlightened you about the topic. In the next meeting, we will discuss kinematics, or the fundamentals of kinematics. So take care.